Well, good morning, everybody, and thanks very much, Magdalena, for this opportunity to share findings from the Shelter Study, Sustainable Housing for Eco-Friendly Living and Thriving Environments. So I'm a senior lecturer in human geography based at the University of York, and I am also part of the team that runs YESI, the York Environmental Sustainability Institute, and we're all about fostering research in environmental sustainability in the many different forms that can take. But I'm going to talk today about these findings from our sort of small exploratory study that was really looking at particularly the barriers around delivering sort of the wider use of bio-based materials and offsite construction in the UK house building industry. So this is the team that was involved. So I led the study, and we had researchers from all across the university in all different departments and faculties, from the Green Chemistry Centre of Excellence, who are doing really fabulous things with innovative bio-based materials, to Louise Cook, who works in historic built environments and does really interesting work around building with earth, to Nicholas Please in Business and Society, who's really interested in housing as a huge track record of housing research, to Nicola Carslaw, also in my department, who's an expert in indoor air quality. So we really tried to do a really interdisciplinary deep dive, albeit within a relatively short study, into the barriers, looking at it from different perspectives. The funding came from my institute, from the York Environmental Sustainability Institute, and we were also really fortunate to get support from the Alliance of Sustainable Building Products. So we really thank them for their involvement in the project. So just in terms of a bit about the background, what sort of prompted the project? Well, there's obviously, we're all aware of these sort of overlapping crises that are happening. We have a climate crisis, an existential crisis, we have housing crisis, building safety crisis, cost of living crisis. And also at the same time, largely in response to these multiple crises, there's a variety of legislation, strategies and targets that are coming forward, including things like the government's 1.5 million homes by the end of this Parliament target, the legally binding net zero by 2050 target. So against this sort of background of crises and legislation and policy, it seemed that perhaps offsite and construction and bio-based materials could provide part of the solution and part of the way of addressing these strategies and targets, because of the reported benefits associated with this construction method and these materials. So things like, for offsite construction, delivering time and cost savings, minimising construction waste, reducing whole life embodied carbon. In terms of bio-based materials, their potential to control internal environmental fluctuations, which can support occupants' health and well-being, their ability to sequester carbon, delaying the emissions of carbon till much later, and their sort of circular potential to be reusable, recyclable and renewable. But given these various benefits, they're somewhat underused within the wider UK house building sector. They obviously are being used by some actors within the sector, but in the wider mainstream house building industry, they're relatively underused. And we really wanted to explore why this might be the case. Past research, which has often not been UK focused, has identified multiple barriers, and we really wanted to unpick whether these barriers were pertinent to, whether they resonated to stakeholders within UK house building. Were the same barriers cropping up? Were different barriers experienced? Were barriers attracting different levels of significance? Maybe the key barriers in one country are not the key barriers in the UK. Maybe different barriers are more prevalent within the UK. So that was kind of the background that prompted our research. Just to say how we defined those concepts, or those that material and methods. So we understood offsite construction as a process of planning, designing, fabricating, transporting and assembling building elements for rapid site assembly to a greater degree of finish than in traditional piecemeal on-site construction. It covers component-based, panelised and modular construction, quite a well-used definition by Smith. And then in terms of bio-based building materials, we understood that as materials derived from once organic organisms such as agricultural straws, hemp, flax, cotton, timber, so on. And that was a definition, again, relevant relatively widely used, although we do appreciate that there are different definitions of bio-based building materials. Some of them extend to things like using earth as well, but some definitions understand earth as being a separate form of materials. But that's how we understood bio-based building materials for the purposes of our research. So the project objectives, we set out to determine the current state of knowledge on barriers to offsite construction of bio-based building materials in house building, identify barriers to using this method of materials, including their use in tandem in UK house building, because that was a particular thing we were interested in. We think both of these, the method and the materials, both deliver benefits, it would seem, and those benefits could be amplified, multiplied if they were used in tandem. So doing offsite construction with bio-based materials, what might be some of the barriers perhaps around doing that? Why is it not used as extensively as it could be potentially within mainstream UK house building? Although again, we know that some people definitely are using bio-based materials with offsite construction. And we wanted to explore the implications of our findings for policy and practice, and then identify key areas to address in future. Because this was a relatively small exploratory study that was to really lay the groundwork for larger follow-on projects. And I'm happy to talk about the kinds of ideas we have for follow-on projects in the discussion section afterwards, and always looking for potential people to collaborate with on future projects. So if you would like to get in touch, we have our contact details at the end, and that would be great to reach out to people and particularly engage with industry people, policymakers, to try and situate our research in the needs of research users. Okay, so the method that we employed, we did a rapid evidence review looking at grey and academic literature that had explored barriers to the use of bio-based materials and offsite construction. And then we also gathered industry perspectives using more qualitative methods, so semi-structured interviews and focus groups with a diverse sample of 15 senior professionals, and things like directors, founders, CEOs, managers, a variety of organisations, including SME house builders, modular developers, different architectural practices, policymakers, community land trusts, and then a number of people involved in supplying bio-based materials or being consultants or using bio-based materials. So try to get a collection of people within that bio-based materials sector involved. And these were individuals and companies based across the UK. And we also topped things off with a stakeholder workshop where we reported back some of our findings to kind of get a bit of a sense check from similar collection of participants about the barriers that we'd identified. Did they seem to resonate with people? So moving on quickly to some of our findings, beginning with findings from the rapid evidence review. So we found that only one recent academic study had considered the possible barriers to doing offsite construction with bio-based materials. And that study had actually focused on reviewing different bio-based materials that could be used, not actually an evaluation of the barriers to using them in offsite construction. The studies that had looked at barriers to offsite construction and bio-based materials independently reported a large number of a very wide range of social, cultural, regulatory, economic and technical barriers. One systematic review alone identified 75 barriers across 46 studies, all around using offsite construction. Studies looked at barriers in the general construction sector or barriers specifically within the house building industry. And generally speaking, the same set of barriers were identified in both the construction industry and specifically within the house building industry. The same broad set of barriers were interestingly found to affect both offsite construction and bio-based building materials. So there wasn't this big cleave between barriers affecting the two. The most commonly mentioned barriers across the literature included higher upfront costs to set up a manufacturing facility and the ongoing costs of keeping a facility permanently operating in regards to offsite construction. That was seen to be the main barrier to offsite construction within the literature. In terms of bio-based materials, things like the higher per unit costs of bio-based materials compared to conventional materials was found to make some schemes less competitive. expensive, reduce profit margins, make them unaffordable to clients. There seem to be misconceptions, limited knowledge and limited experience across the construction industry of bio-based materials and of off-site construction, which leads to their limited use. It seemed to be costly, complex and a lengthy process around obtaining accreditation and warranties and demonstrating compliance with regulations for methods and materials that were perceived as being innovative, which off-site construction and bio-based materials were perceived to be, according to the literature. Building regulations were seen to, or reported within the literature, to favour conventional construction methods and materials, particularly for bio-based materials. There was seen to be real challenges around fire safety regulations and fire testing regimes that favoured conventional materials rather than recognise the particular qualities of bio-based materials. Particularly for off-site construction, building contracts and procurement models, the traditional ones that are favoured within the construction industry and used by clients, the design, bid, build approach, was seen to be unsuitable to the way off-site construction needs to be delivered. The off-site construction requires the greater engagement of all different parties at a much earlier on in the development stage, developing a design independently and then trying to retrofit that to the processing practices of an off-site manufacturer was seen to be not an optimum way to do off-site construction. It was far better to create the design in conjunction with the manufacturer. So you were making the most of the efficiencies possible from off-site construction. Moving on, risk-averse orientations in the construction and finance industry were identified, which would reduce or seem to reduce the use of off-site construction and bio-based materials, and made getting things like insurance and mortgage finance and general funding more challenging. There seemed to be insufficient production and manufacturing capacity to support larger projects, both in terms of off-site construction and bio-based building projects. There seemed to be insufficient data on the benefits and performance of off-site construction and bio-based building materials, and this was seen to make it more challenging to demonstrate compliance, and also could raise issues around working with insurance providers, for example. And there seemed to be limited public knowledge of both off-site construction and bio-based building materials and their benefits. So there wasn't this wider market demand. There was certainly demand from niche areas, but a wider appetite across the wider house buying public wasn't seen to be there, and there was also seen to be perhaps some skepticism and anxieties amongst the wider public about these potentially more innovative method and materials. Almost wrapping up on the evidence review findings, just in terms of studies that had looked specifically on the barriers around using bio-based materials with off-site construction, we found very little research on the barriers around this, and in fact very little research overall on looking at using bio-based materials with off-site construction. The barriers that were reported in the odd study that had looked at this identified the properties of bio-based materials can create difficulties for and increase the time and cost of off-site construction. The fact that bio-based materials are generally so variable, they don't come in a uniform form, and also the cost and ease of obtaining prefabricated bio-based components was seen to be problematic. Just on that last barrier, it was a bit unclear from the study that reported it whether the challenge referred to difficulties getting finished prefabricated components made from bio-based materials, and or whether it was around difficulties in actually getting an off-site manufacturer to produce prefabricated components. So it could be either, it could be both. Wasn't too clear from the study. So turning to our findings from our primary data collection activities, gathering perspectives from different industry actors. So we identified a range of challenges that were reported by our participants, but there were far fewer challenges than reported across the wider literature. Many of the barriers that our participants identified reflected past findings, but there were some differences, and I'll pick those out when I run through the findings pretty briefly. Beginning with barriers to using bio-based materials, the key barrier reported by our participants was the lack of a supportive policy environment. Fire testing regimes and fire safety regulations were found to limit where bio-based materials can be used in a building. Insulation standards in building regulations were seen to respond to the properties and performance of conventional insulation materials, which was seen to result in larger volumes of bio-based insulation materials being required, which increases the cost and can also impact property and scheme design. You might have to have thicker walls. You might have to be able to fit fewer properties onto a site. Some participants reported planning officers and building control officers could be resistant to bio-based materials, but conversely, other participants reported positive experiences with these regulators. There was a general view that a policy prompt needed to move the mainstream house building industry towards the wider use of bio-based materials. And several participants identified how a positive policy environment that was pro-bio-based materials had been key to expanding the use of bio-based materials in other European countries and their bio-based materials industries. So they gave examples like Sweden and France, for example. It was noted that bio-based materials can be more expensive than conventional building materials, but at the same time, participants reported how these materials can serve more than one function. They can reduce heating and cooling requirements, they can reduce a building's operating costs, and they also noted that the kinds of clients they were working with tended to be motivated by the properties and benefits of bio-based materials, like their potential to support health and well-being or reduced embodied carbon, not so much this underlying or specific cost of these materials. So we might perhaps question whether that orientation of their clients would apply across the wider house buying public. And I think that would be a really interesting thing to explore further in future research. Across the construction sector, there was seen to be limited knowledge and experience of using bio-based materials, and there was really wide support for providing training for people at all career stages, from students to experienced builders and tradespeople. Differing from some past findings, our participants didn't really report any issues with mortgage finance and insurance. They reported that complying with building regulations, using accredited bio-based building materials accredited by organisations like BBA, and for some of the offsite developers that were using bio-based materials, then accreditation by Build Offsite Property Assurance Scheme, BOPAS, was seen to give confidence to mortgage providers and insurers. Also, our participants reported that the supply of bio-based materials was sufficient to meet the needs of the projects they were delivering, but they did note that there was a reliance on importing products from overseas, a lot from the EU, and there was some comments around how Brexit had made that more tricky. Turning now to some of the findings on barriers to the wider use of offsite construction. The need for a continuous pipeline of demand to support the continuous operation of a manufacturing facility was identified as a key barrier. It was seen to be very expensive to have a factory standing idle if there wasn't a demand pipeline running through. You still have the overhead, you still need to pay staff. It's not like being able to kind of pause work on a building site. Planning delays and house builders' typical business models that rely on building properties only once they're sold was said to be important barriers in maintaining a continuous pipeline of demand to feed through a manufacturing facility. The traditional procurement model of construction, used in construction, and resistance to using alternative procurement models was seen to be another key barrier. As I mentioned earlier, the traditional approach, the design bid build approach, was seen to not really fit with the way offsite construction needs to work. There needs to be earlier engagement with all parties in the development process than that model typically allows. We found that the house builders that we spoke to who used offsite construction successfully had bypassed this sort of a design bid build approach by integrating the design, manufacturing manufacture and assembly functions all in-house. So they were able to design and deliver schemes sort of as a whole, as a holistic entity. Risk-averse attitude across the construction industry was also seen to be a challenge in response to offsite construction, which could have an impact on both clients and mortgage providers and insurance operators at times for some people. The issue around variation in planning requirements across areas and clients and home buyer preference for personalisation to have a house that looks different from a neighbour's house, or a block of flats that looks different from another block of flats, was seen to work somewhat against the ability to deliver efficiencies at scale through offsite construction. Offsite construction tends to rely on delivering uniform components and uniform units, certainly if you're doing modular. And so the preference for homeowners to have variation and variation in planning requirements across areas, so you can't sort of roll out the same property across many sites, was seen to be a bit of a challenge, although using panelized approaches rather than modular was seen to be some way to deliver a degree of personalization and variation while still having a degree of standardization. Differing from some past findings, our participants didn't really report issues of limited knowledge of offsite construction across the construction industry, at least no specific challenges around limited knowledge of offsite construction. There were seen to be general issues of knowledge needing to be developed across the construction industry, but it wasn't specific to offsite construction where there was a knowledge gap. Mortgage finance and insurance were not really seen to be barriers. Overall, a couple of people did mention some issues, but generally they were not seen to be barriers. It was seen that in the past there perhaps had been mortgage finance and insurance had been a barrier, but evolution in the industry, evolution of thinking within mortgage providers and insurance providers had now meant that there weren't such barriers. Moving on. Using bio-based materials in tandem with offsite construction, our participants didn't really report many barriers at all to doing this. Just the odd issue was noted, but it wasn't sort of emphasized as a particular impediment. There was some concern about load-bearing risks at stackable modules if they were developed for a very high buildings, many stories, if they were developed with bio-based materials. And there was also a little bit of comment expressed about the potential for movement of certain materials during transport. So the movement of some materials in some forms of natural insulation and what the implications could be of that. But generally speaking, there were very few barriers mentioned. They weren't particularly emphasized. And in fact, rather than identifying barriers, our participants identified success stories of integrating bio-based materials with offsite construction. So they spoke about integrating natural insulation in panelized units, also doing offsite timber frames for houses as well. A very common approach. A number of our participants were discussing that. I suppose just a couple of comments then, given sort of these very positive reviews that our participants reported, a couple of comments about putting our findings in context. We appreciate we worked with a small sample of participants, although it was a diverse sample, and it was all people, senior people, that generally had rather positive experiences of either offsite construction or bio-based materials, or using bio-based materials with offsite construction. So we could question whether the same stories, the same experiences would be presented by a wider sample of people, including those who had had maybe less positive experiences with this method and materials. That being said, Our findings do have a number of implications for policy in practice. Some of the sort of the broad areas of attention we think our policies, our findings speak to, could be policymakers and practitioners exploring opportunities to create a more positive, supportive regulatory environment for both bio-based building materials and off-site construction, investigate and promote alternatives to house building's traditional procurement structures and business models, activities to develop house builders' knowledge of bio-based building materials, supporting companies with the cost of establishing processing facilities for bio-based materials and manufacturing facilities for off-site. So those could be some sort of broad areas of action and attention. And in terms of some more targeted actions and attention within those broad areas, we suggest that a fruitful area of future work could be assessing the content and impact of pro-bio-based building materials policies in other countries, such as France, with its environmental regulation 2020, which looks at embodied carbon in addition to carbon emissions and seems to be helping to really drive the use of bio-based materials, and looking at whether they could be applicable to the UK. Also, we think that there could be scope to evaluate the impact and limitations of procurement frameworks that support the procurement of off-site housing, and findings could inform the modification of current frameworks and/or the creation of new frameworks. We also think there could be more opportunities to explore increasing or further promoting the use of off-site construction in publicly funded housing, for example, through the Affordable Housing Programme. It is promoted at the moment, but there was, for example, a House of Lords report that suggested that promotion could go further within the affordable housing programme. And lastly, we think that we should be monitoring and evaluating the impact on planning delays of recent and forthcoming planning reforms and use that to inform future plans for reform, given the issue of planning delays and its particular implications for off-site construction. Obviously, we want to see if any of the reforms being introduced would further increase planning delays, although the objective behind these reforms is about speeding up the planning process. And that's our summary of our findings, which you can access from the website there, the web link. I've also got hard copies. If people would like to get a copy, we can send hard copies out. And as I said, really keen to engage with people, explore if there's opportunities to collaborate on projects going forward. So my contact details are there as well. So thanks very much.
Thank you, Catherine. That was brilliant. One question before we move on to Patrick. What's in store for the next stages? What would be the main focus? Because you said that there are obviously loads of ideas. Could you tell us a little bit more about it?
Yeah, so a couple of different ideas, as is always the case with researchers. One of them is looking further into market appetite for the use of bio-based materials in off-site construction. There are certainly particular clients that are really gung-ho about it. But what's the wider market sentiment towards the use of this method in conjunction with these materials? Is the support, are there anxieties? What might be those anxieties? How could they be overcome and addressed? And then sort of linking into actually some of Patrick's work, which we'll be speaking about shortly. Really interested in looking at the scope for bio-based building materials for use in energy retrofit. We obviously need to improve the energy performance of our enormous existing stock of housing. Most of the housing we're going to be living in 2050 is already on site, is already here. I think something like 80%. So it's about looking at how can we retrofit that? How can we do that in a sustainable, climate conscious, health and well-being conscious way? And what might be the scope there around using bio-based materials? So sort of drilling down further on the bio-based materials route with that other project, which we are developing a proposal around.
Perfect, thank you. Right, okay, well, we'll move on to Patrick now, and then we've got a raised hand from Sally. Sally, would you like to come in and ask the question?
Yeah, sure. Can you hear me all right?
Yeah, we
Yes.
can hear you fine.
Okay, just a quick question. Did you talk to any manufacturers who might be in a position to transfer from petrochemical-based insulation, for instance, to a bio-based alternative? Did you talk to any manufacturers or anybody in the supply side?
No, we worked in terms of the suppliers, we did work with suppliers within the bio-based building materials industry. So that is one of sort of known limitations of the study, that we worked with people that were sort of already engaged in this, either of those sectors, and generally had more positive experiences. But future research, it would be great to reach out to a wider range of participants.
Katherine, thanks for that. I think you'll see some overlaps between our projects. We're currently have just completed a critique of innovation in relation to building regulation compliance amongst the 5 partner nations. And we're writing up a paper and policy recommendations on that, which you might find interesting. And I think we'd be very interested to see your report on your findings, and we might be able to integrate that in some way. So thanks very much for your presentation. Okay, so I'm going to talk about the Circular Reno project. Some of you may have seen some of this before. So we'll give an overview of the project, what we've been doing to date, and particularly more recent research, especially focused on straw, which is one of our main resources. I'm going to skip that one because it's not working. So just to talk about what Circular Reno is, it's a EU Interreg Northwest project. So that they're the funders, and it's seeking to develop modular bio-based construction materials from agri-crops in particular. So that's the feedstock scope, and looking to apply that in modular construction retrofit within social housing. So the concept there is to basically connect farmers with processors and manufacturers to grow and supply, and for manufacturers to supply into housing associations, and over 4 sites to retrofit 88 homes as a demonstrator, and then to educate and engage up to 80 public authorities to begin to use the same solutions. So that's in effect the high level overview of the project. There's 3 work packages in the project, just to give you an overview of those. So in Ireland, the main partners are Tua Housing, who are a social housing provider, and Core Retrofit, who are a large-scale retrofit one-stop shop company doing retrofits and in relation to government grant schemes, etc., at large scale. So the 3 work packages are: work package 1 is about supporting the sector to develop supply chains, and that's the one we're focusing on and reporting on today. Work package 2 is focusing on undertaking 10 deep energy retrofits of social housing. And then work package 3 very much relates to what previous speaker has been discussing, which is about trying to shape policy, legislative interventions, etc. So it's about how to upscale the solutions and make them more widespread across Europe. But really the focus of what I'm talking about is mainly work package 1 and some of work package 3. So what are we talking about agri-crops? Well, we've been limiting our scope to mainly tree materials, although we've expanded a little bit into grass. We've been looking at straw hemp and miscanthus, and we can see that there's a diversity of products from boards to bats and quilts and blocks, but even some use of what we might call fundamental elements within these materials, like cellulose and lignin, are being used as additives to other construction materials. So it ranges everything from materials to products and also to systems and particularly modular systems. And I think that's another overlap with your own project, the shelter project. So we're seeing straw, hemp, and miscanthus now being integrated with a number of modular manufacturing systems across Europe, including, of course, the UK. That's quite an exciting development. One of the key things we've been trying to do is to bring together people across the supply chain in Ireland. So quite a complex supply chain, spanning agriculture, processing, manufacturing, and construction, each with their own codes, standards, market forces operating on them. So quite challenging, but that's the complexity of supply chain that's needed in order to actually get these products into construction. They all need to be engaged. But just to go back and look at, to remind ourselves why bio-based materials are critical, and I like to start with actually their building performance properties. So, you know, there is research, and it has been documented that they do have some performance advantages, mainly the regulation of moisture, and also not only resistance to the transfer of heat, but also the capability to store that. So there is an ability to create both moisture stability and temperature stability, and also good acoustic performance. So there's some important advantages, building performance-wise. There's the obvious environmental advantages of storing CO2, the potential for biodegradation, which means it can go into the biocycle wing of the circularity butterfly. And also it can go into other valorization applications within the bioeconomy. And of course, then socially, we would be supporting and creating regional jobs, particularly rural development and farm diversification, and healthier buildings, which is really critical. So huge circularity benefits from the use of biomaterials. A lot of the circularity literature is biased toward the technical cycle, reuse, reapplication, remanufacture, etc., which is great. But actually, the other side of the circular concept or framework, particularly from the Ellen MacArthur Foundation, is the reapplication of the materials within the alternative cycle, which is the biocycle. So there's a whole range of valorization, energy extraction, and at the very least, going into normal, if you want to put it that way, natural biodegradation into the biosphere. So there's significant advantages there to using these materials, as well as the fact that you're offsetting and replacing, in many cases, materials that are coming from more energy intensive and finite resources. So the fact that they're also renewable. So I think that's an important dimension of circularity that's sometimes not emphasized sufficiently. As part of our work early on, we did a study looking at the application of these materials in Europe, ignoring farm direct straw bale, which is quite significant across Europe, and just looking at materials, products, and systems. And across Europe, we've seen that in terms of material and product manufacture, hemp is quite dominant. Is the big message from that. And there's the diversity of materials that are being used within each of the, this is from a survey of 57 companies across Europe, the materials that are being manufactured and the agri-crop resource base, feedstock base. We also then tried to come up with a classification of how these materials are being developed in terms of very simple low-tech solutions like straw bale, up to more high-tech solutions that might include advanced processing, etc. So we've tried to develop this simple classification scale and to see where each product is sitting within that. That's also to do with trying to assess the complexity of the supply chains that are being developed. So that would hopefully give you an overview of some of the main applications. And interestingly, I think, and quite more recent in the last decade, is the emergence of modular systems integrating these agri crops. And here it's actually switches to straw being the dominant material and secondarily hemp. So we found something in the region of, as this work grew, starting at 13, I think going up to something like 15 or 17 modular manufacturers across Europe that are integrating agri crops into their systems. And again, they're quite diverse, dominated in straw. I mean, we try to map those also in terms of categorization. So there are a whole range of wet and dry systems. It tends to be dry dominated. In terms of the framing, there's both single and double studs. Again, the companies that are transitioning or using wet systems tend to be single studs, and the companies that are using dry straw and effectively designing their systems from scratch tend to be going twin stud. We're also seeing differences in the type of panel systems, whether they're partially closed or fully closed, and then the type of element that they're being applied into, and also different strategies around panel scale. So some of them are small Lego type panels, and others are larger, full bay or full elevation, full story height panels that are crane lifted. So there's a whole diversity of strategies about panel types, panel transport, etc. So that's quite an exciting sector that's emerging. In the Irish context, then we looked at what was happening in Europe, and we could see that most of what's happening in Europe, they're building on existing feedstocks. So they're not really trying to establish new feedstocks. France, they built on their significant hemp industry, which already exists. And in continental Europe, they're building on the massive straw resource that they have, etc. So looking in the Irish context, we began to look at these resources and how we can get them from farm, in a sense, to construction. So in our context, our biggest resource is actually grass, which is why we began to expand that out. And we've seen some grass-based construction materials on the market in Europe. So we think that should be considered because we are a pasture-based economy. In terms of agriculture, 82% agricultural land area is dedicated to pasture. And even our tillage sector is partly about providing feedstock for the animal stock, which is primarily cattle, over 9 million cattle in a nation of 4 million people. So of that, straw is our biggest resource at over 250,000 hectares. And hemp and miscanthus are really niche. There's less than 1,000 hectares. So they're very, very niche crops. They're at current scale, they're not really the crops that you could build a large scale industry around. Yeah, they're, one large farm would swallow them up in that sense. So we began to focus in on trying to prioritize that. Maybe strategically straw should be a priority, and miscanthus and hemp should be secondarily in terms of developing a national supply chain. And we have developed supply chain pathway maps, which I think are quite helpful. They're not Irish specific, but they were conceptualized within the Irish context. But the supply chain routes of where materials can go through different levels of processing, from simple processing to more advanced, and then the range of manufacturing approaches, I think would apply really anywhere, and then the main applications. So we've mapped these out. We've been working with a supply chain development group in Ireland for each of the three materials. And that's been quite helpful. Parallel with that, we've developed guides for farmers about the main resources. Obviously, straw will be very well known in the Irish sector, miscanthus and hemp less so, but there are niche plantations, so we know they can be grown. We know there's experienced agronomy data now about these crops, so it's way beyond trials at this stage. We know they're viable in the Irish context. But we have identified barriers across the supply chain itself, and some of them are quite strategic, including the lack of processing infrastructure, especially for hemp. Whereas we have some processing infrastructure in place for straw for animal bedding. So again, strategically, it's quite an important product. So because of that, and because of the emerging focus on straw in Europe, we've begun to look at our straw resources and begin to do material property testing for processed straw, mainly chipped, but we also now have some fiber straw as well. So we've begun to look at it, and we've also recently tested. There are several companies across Europe that are blowing in straw as an insulative infill with under a European assessment directive for vegetable fiber blow-in insulation. So it fits within an existing recognized European directive, which means it can get CE marking and could possibly expand it into Ireland. So we've been doing some experimentation on the material properties, but also on its performance. And key is density. Density dictates thermal conductivity, and density also dictates oxygen levels, which impact on fire transmission across the structure. So we were experimenting to get optimal densities to balance both the fire risk and thermal conductivity needs, which we achieved. So that's very promising results. We are also beginning to look at grass, both harvested grass and the emergence of grass anaerobic digesters. So there's very possibly a type of pulp that will come out of those that will be grass-based and effectively be a waste stream for valorization. So we're just doing early research on that. As part of that, we've built test panels for looking at how these materials could apply as modular overcladding on internal and external retrofit systems, be that applied on site or prefabricated. And we're also developing what we're calling a biopod, which is a research pod where we'll have up to, I think, 5 or 6 established manufacturers showcasing their construction materials, but we'll also be having around 12 test cells in roof and floor application where we'll be testing Irish material. They're the range of materials being installed into modular panels, and they were installed internally and externally in an office building, and we're testing them mainly for thermal transfer. We also have density, thermal conductivity, and some analysis of moisture levels. This is the pod that's in design at the moment and will become a research demonstration pod for bio-based materials, fully modularized to be able to disassemble down to flat pack and reassemble and be transported, hopefully to different universities. We've also done some work on carbon trading. So we've been working with our European partners to map out the emerging carbon trading mechanisms within the different partner nations, Belgium, France, Netherlands, etc., as well as watching what's happening in Europe, where the framework for that is being created. So there are a number of pilots, particularly the Netherlands have a pilot for carbon trading within carbon support for bio-based materials. So they're really, the Netherlands have really moved beyond technical validation of solutions into supply chain upscaling, and they see carbon trading as a critical part of that. Interestingly, for the shelter project, we have done an analysis of building regulation compliance. This is just a simple mapping of our own Irish building regulation compliance pathways. You can have European certification, and it may have some validity, but not fully valid in Ireland. And then in Ireland, you could manufacture under an approved standard, so you don't need to do any further testing. Or if it's a new product, people tend to go for an Agrimont cert, as they do in the UK. But there's also opportunity to use other independent certification schemes and even data from a performance in use, but not generally done. So we're looking at just recently have completed a report looking at building regulations and compliance pathways for innovative and bio-based materials across the 5 partner nations. And we're developing policy document out of that, which could be of interest. Some key dates, if you're around and you want to come to Ireland. We're doing a dedicated farmers training on the 11th of February in Ireland, where we will be basically showing the farmers the materials and the construction applications, and then working back to the feedstocks and encouraging them to begin to consider either diversification or utilizing existing resources that they have. As we say, we have 250,000 hectares of straw. It's our biggest tillage crop. And that's effectively, there's a waste stream out of that can be valorized. We're planning for a 4th and final training workshop and seminar in April, maybe mid to late April, I think, is what we're looking at. And we hope to be doing some demonstration there of actual solutions as well. And then a final project conference toward the summer, June, July, as the project ends then in I think it's the end of June or July itself. So there's some key dates. So overall, it's our final year of the project. Bio-based materials are being more and more seen as a critical part of Ireland meeting its climate targets, that without a decarbonised construction sector, the targets can't be met. There are very significant carbon storage, but also circularity benefits. So I think as circularity metrics become more common, bio-based materials will play a role in supporting advanced circularity performance as well. I think it's fair to say it's no longer about technical performance. The real issue is, can we develop supply chains and the sector so that this can be done at scale? Because scale is what will dictate cost and the ability to re-educate and transform the sector so that it becomes effectively normal and overcomes all the perception barriers. I think scaling is the critical issue, and that needs to happen all along the supply chain. The range of agricultural crops is significant. We already have huge resources. If we take grass and straw in Ireland, we have enough material actually for the whole construction sector, really. But we can also expand the niche areas like miscanthus hemp, or return to old crops like flax. So the diversity of agri crops, there's a huge potential there. We want to continue the research and development of straw and grass. As I say, we're now working on we've already built our test retrofit panels. and we're building a new modular floor roof wall systems into a pod. So that will be interesting. And our final workshops and conference are coming up. Hopefully that's given you a good overview of the project. Contact details are there. Of course, I have to mention Paula is here and is research assistant on this and working really now full time on the Circular Reno project and has done extensive work on this. So very happy to connect with people, take questions, and help support the transition. Thank you so much.
Thank you, Patrick. Thank you so much. Yes, please do reach out to Paula and Patrick. Paula is amazing. She gets back to you so fast. I really always appreciate her keenness to link up people and to share what Patrick and Paula have been doing. Patrick, before we move on to questions, because the chat is quite active, which is great, I wonder if you would like to tell us, maybe you said that this is the last year of the project. What next?
Yes. Well, two things really, and it links back to the question that Sally brought. Hi, Sally, haven't seen you in ages. The project has been, the main partner is Core Retrofit, but they're also an insulation manufacturer. They have two companies, Core Insulation and Core Retrofit. And they're really, this project, I think, has really opened their eyes to the transition to bio-based materials. So they're actively looking at maybe developing a bio-based insulation product. So out of this, they're really looking at that. We're also looking at a follow-on Horizon 2020 application with partners in Spain. And so we're currently at drafting stage. I think Horizon 2020 is February for submission. So we're looking at a call that again is going to look at bio-based modular systems. The concept is to try and do all the groundwork to develop a short matrix of systems that could be applicable across Europe using existing materials. So that all the facade analysis will be done. So it's a TRL 1 to 5. But it's not really about product development, it's more about systems development. So we are looking at a follow-on project and are very keen to continue the work that we've done. We think there's huge potential for developing bio-based products in Ireland. Other than the only two products we really have would be things like OSB and Medite wall boards and cellulose insulation. So and of course our timber construction materials. But we've no boards, bats, or quilts or insulative infills. Most of it is very niche and is being imported. So if we're going to upscale, we can't rely on imported. I mean, the costs are extensive. When we looked at the cost of some of the material, the transport cost is nearly half the cost in Ireland. So if we're going to have a radical upscaling, we need to develop regional supply chains and whole effectively industries that don't exist out of that. But I think the good news is there is interest there. So hopefully we'll find something. Maybe we'll be partnering with friends there in York and doing something together.
Perfect, thank you. And this is sort of what Sally touched on as well with a question to Katherine. Can we speak to the people who are maybe have not been in the past interested in bio-based products to gauge if they would be interested to invest or even, consider use of such materials? One of the things that you mentioned, which I was really wondering if both you and Katherine could maybe expand on a little bit, is Katherine was talking about manufacturing facilities. There's been a comment in the chat as well about manufacturing facilities being a major block, I suppose. Patrick, you're talking about localized supply chain. You've also done a lot of work trying to look at the alignment of agriculture and construction sectors, which can be quite challenging. What are we talking about in terms of manufacture, about the supply chain, about matching the supply and demand, and how is it different in Ireland, in the UK, I suppose? Maybe start with Patrick.
Okay, well, the manufacturing scene is very diverse, and what the products, depending on what type of product one is aiming for, the manufacturing becomes more complex. So, we've tried to categorize it that there are very simple solutions, like just taking hemp shiv, mixing it with lime, and you have a limecrete. That's pretty low tech, except the level of processing for that, the decortication, is quite significant investment and needs scale. It's going to need 1,000 hectares of agricultural land just to supply one processor, at least, I would imagine. So then you can move up the scale, and if you want to manufacture a quilt, an insulated quilt from a bio-based material, you're going to need fibers, so you need to process further for fiber, and you're going to need a manufacturing line that can roll out fibers, integrate them, add a retardant, or a binder, etc. So it becomes more. You have advances in levels of processing need to keep increasing, and also levels of manufacturing, and all of those require investment. So we're proposing something that we've seen is being proposed in the Netherlands, that supply chains are started on the most simple resources with the least amount of processing. So just simply chipping it's so cheap. There's people chipping miscanthus for animal bedding. There's people chipping straw all over England, all over Ireland, all over Europe. So it's a highly available resource. It can be refined quite quickly, and quality can be improved. And that material, if pumped in under pressure with low oxygen, can achieve, it won't achieve, it's only going to be Class E for spread of flame, but it can help resist for transfer across the construction. So that's a very low-tech, quick supply chain that can be developed with minimal investments. And then from that, you could expand out into other levels of processing, fiberization, etc. But all those increases in processing costs and manufacturing costs need to be gained back in the sale price of the product or material. So they all increase cost. And again, to get costs down, we need that at scale. So there's a volume demand so that it can be produced at scale. And once you have scale, you have competition. So I think there's a need to be to strategically support the supply chains to happen sequentially, that there's a baseline material, baseline processing, and you build from that and advance up the technology scale, both in terms of processing and manufacture, to eventually, very highly refined, well-manufactured products, which would probably, be advanced boards and advanced quilts and bats. But working back down, it's easier to start with more simplified solutions. So I don't know if that helps, but that's what I think is the answer to your question.
Perfect. Thank you, Katherine. Oh, you're on mute.
Just in terms of that issue of scaling up, our participants reported that there were issues with the local supply of bio-based materials due to land availability, competition for land use, and just the existence of large manufacturing facilities, and then the cost of creating those. And so this was producing the reliance on importing materials from overseas, particularly from Europe. I suppose there was a little bit of a chicken and an egg thing. That there was, from at least a couple of participants, a comment around how much the UK market would need to grow in order to justify the cost of creating a large local manufacturing facility and investment in large scale production of one of the crops that Patrick's been speaking about. So it's kind of what's going to come first, creating the supply or the demand. And at the moment, the supply is coming from overseas because there's larger local markets there to support. And this comes down the suggestion around the supportive policy environment to overcome some of those cost barriers. Because I guess if things just continue as they are, then I guess people may just continue to keep importing things from the EU and elsewhere because that's where the suppliers are. And if there's always the alternative to go there, then I guess the local market may not sort of grow. In terms of the offsite manufacturing, I suppose it was just around the cost of creating factories specifically for modular units. That was seen to be a particular issue because they're sort of less flexible. So if demand was to stall for a period of time, there's less opportunity to sort of flex into a different market, deliver a scheme for a different developer. Whereas if you did panelize, that introduced a greater degree of flexibility. So I suppose it was around maybe where the scaling up could be in offsite manufacturing, it would be the development of panelized manufacturers rather than the modular ones. It was also a comment around the amount of land that needs to be available to house particularly modular units if planning delays or other delays was to make it not possible to just immediately transition your unit to site. Then just the amount of land and the cost of renting or owning large amounts of land in order to store modular units implies you can store more panels in smaller space. So it could be a more cost efficient, but again, public sector investment in supporting operators to create manufacturing facilities was seen to be really important in helping to scale up that industry as well. But obviously the demand, again, the chicken and egg thing, the demand needs to be there to sort of, particularly for people like venture capitalists and similar kind of private equity organizations, the need for a quick return on investment, and the fact that offsite is not, it's going to take a while to start recovering the large outlay of creating one of these high spec manufacturing sites.
Perfect, thank you. Well, when we come back to the policy, but I've got a couple of questions in here that I think we should probably answer. So one from Nick is around fire regulations. So he says, there's been little discussion about the fact that all of the materials are Class E combustibility or fire spread, and how do we address this? And then there's another comment that I think kind of marries up with this and bringing or understanding and shifting the liability for the specification as well. My understanding is that Ireland has had a principal designer for building regs role for a long while now. Has this assisted a transition to bio-based materials in Ireland? The reason I ask is it seems to have been a cause of some stress and anxiety since starting in England, and I suspect this will soon come to Scotland. And if Katherine could touch on the barriers for bio-based materials getting through regulations. Yes, quite an extensive question, but I think it sort of, the fire side would be dealt with by the introduction of the principal designer, and then Patrick can maybe tell us a little bit more about how does it work in Ireland. So we'll start with Katherine.
Yeah, so certainly for our participants that were engaged with bio-based materials, whether they were manufacturers or suppliers or developers or SMEs that use them, then they did all mention the fire safety testing regime and fire regulations were seen to be a particular issue if you were building certain kinds of properties. So, higher, taller buildings, where you simply under our regulations can't use them because of the classification. So there was a view that the current testing regime and standards sort of were developed in response to conventional building materials, and so responded to the properties of those conventional materials rather than the particular properties of bio-based materials. They are different, so they do perform differently, but it's how the testing regime and the standards really sort of more a blinkered view, focusing on the properties and performance of conventional building materials. I guess because of recent experience of tragedies like Grenfell, there is a huge cultural view on the safety of building products that perhaps the UK has that maybe certain other countries don't have, or haven't had such recent experience of. So, for example, if you look in Sweden, since sort of 1993, they've had a different approach to the use of timber in higher rise buildings. So they're, delivering buildings of 16-story with timber. I assume that there'll be treatments and processes applied to timber to increase fire resistance. There can be some issues around those treatments and processes. They can have their own consequences, health effects. They increase the embodied carbon, particularly if they're derived from fossil fuel-based materials, then again, it can increase the embodied carbon. But I think having a look at the policies and approaches used in places that are using timber and other bio-based materials in different contexts than we're at the moment enabling, I think would be really valuable work, and seeing if it is something to do with social and cultural attitudes, which has helped to shape policy in a somewhat, and legislation in a different way than it is progressing within the UK. Obviously, things like the recent introduction of the Building Safety Act and the implications of that.
Thank you, Patrick.
The Class E issue is in one sense unavoidable, but the solution is that these materials tend to be lined with something else that's providing the main spread of flame resistance. So that's typically what's happening. They're either providing, whether they're a board or an insulative infill, they're not the finish, and there is something else providing resistance in terms of spread of flame. It is important. The transfer is also an important dimension. So one option has been to add fire retardants. That creates an end of life circularity issue, because you now have something that may have a toxic element within it, or even the binder maybe have elements of toxicity. So these simpler solutions where we're not putting binders and we're not putting a fire retardant in, and we're relying on basically limiting the oxygen within the buildup, to me seems quite attractive from a holistic point of view, and is probably a way forward in terms of optimizing the circularity, the carbon, and also meeting fire performance. So again, technically, it's effectively solved. These materials are within conventional constructions and they're within modular assemblies, and they're meeting fire classification. The challenge about fire is the testing costs. If we're going to, it's part of the building regulation compliance process. So either we allow 30, 40 individual companies to go through that process, or we develop a standard and the standard does it on their behalf, and that opens up the market. So it is a technical issue. I think it is solvable under different specification approaches. I think the bigger issue is the non-technical one, which is the insurance in Ireland. There are insurance companies that won't insure timber frame, let alone bio-based materials. So it's quite a barrier here. And the question about the science certifier, etc. Again, the Irish sector is very, especially for, let's call it large scale construction, if you're doing a one-off house, you may find we might use the word eco-architect or someone who's more experienced with these materials who might give opinion on compliance. But once we get into large scale, architects, engineers will not specify unless it's an Irish standard or has an Irish ICO cert. And even with that, there are insurance companies that will not insure. So we've got to design or educate the insurance sector as well as the regulatory side of things.
And Patrick, is your experience, are they willing to talk about it? Because I think from our perspective, insurers, insurance is one of the main barriers from the liability perspective of people who want to specify these things, but also then later from the owner perspective. And I wonder if, public sector housing, which is what both of you had spoken about a little bit, is that who can take an element of that risk? Is that the client who's very aware that there are benefits, long-term benefits to specifying these products and testing them at large?
One would hope that. I think the Irish, we have, in terms of social housing, we have two main providers. One is the local authorities, who are effectively funded by central government, very risk averse and very strict with their budgets and what they can do with their budgets. And then the other one is our social housing providers, who are actually indirectly funded by central government. So while we talk about the potential for innovation in public housing, we're not seeing it. Not in the way we will be seeing in the Netherlands, where whole supply chains are being developed in partnership with local housing associations who are committing to 10-year contracts for bio-based materials, and therefore creating the pathway for strategic investment regionally in processing equipment and manufacturing or whatever is needed to supply that product. So the conservatism in the social housing sector in Ireland is quite strong, partly because they are both funded by central government and it's quite rigid.
And do you think that having a bioeconomy action plan in Ireland has helped? We obviously don't have anything that directly translates in the UK just yet. Is that perhaps a driving force behind some of these solutions being considered?
It's a good one. There's a lot of talk and there's a lot of cooperation and mapping, etc. And it's spearheaded, I think, some research and development. So I think in terms of awareness raising, and that's across the board, in terms of awareness raising, the bioeconomy action plan and the activities that are coming out of that have been really good for the sector, for all the sectors. And there is an emerging realization that as a country, small country with a strong agricultural sector, that there is a sub-economy to be developed there, and obviously bioconstruction fits within that. But I don't know if that's translated into any significant strategic investments or anything. That's hard. I don't perceive that at the moment.
Okay, perfect. Thank you. I've got a question for Katherine. Could you expand on the basis of your findings that mortgage and insurance were not identified as barriers? It would be helpful to understand the scale of the interview sample that informed this conclusion and whether participants were referring specifically to bio-based offsite systems, to bio-based materials more broadly, or to offsite construction using conventional systems.
Okie doke. So as we said, it was a small, unrepresentative sample of participants that we worked with. So that is a limitation of the research. So we worked with 15 different senior professionals from across the offsite construction industry, SME house building sector, suppliers, manufacturers, and developers / consultants of bio-based materials and a few policymakers. So the view that insurance and mortgage weren't particular barriers, that came out in response to using both bio-based materials, off-site construction, and using bio-based materials in conjunction with bio-based materials. It was suggested that things had changed over time, and they certainly were barriers in the past, but only specifying and only using bio-based materials that were that had warranties, that were accredited, that had adequate performance data, going for getting a BOPAS accreditation if you're doing off-site. These kind of mitigations were seen to be ways of addressing reluctance amongst insurers and mortgage providers. Also, even little sort of tricks, which seem to be how developments were described. So saying, for example, a house, rather than talking about the use of hemp insulation, instead saying it's sort of timber construction with natural insulation. Apparently that could, depending on which mortgage advisor you went to, that could be it could be an easier way to pass through the mortgage process than starting to talk in more detail about the specific types of bio-based materials that were being used, because they tend to be less familiar to people within the mortgage industry, for example, and then that would raise concerns about the level of risk. So small sample of people that were working successfully with offsite and with bio-based materials were reporting that they were challenges. So we do appreciate that if you're going to engage with a sample of people that had more negative experiences, then one might expect challenges perhaps in those areas to be identified, because they have been identified in previous studies and in non-UK studies as well. So it's kind of an interesting wider financial orientation, financial market orientation, it seems, particularly maybe to bio-based materials, which are relative to the perhaps off-site.
Thank you. And I've got a slightly different question for Patrick. Can any agri-crops have multiple uses? For example, seeds for food, stocks for construction, or is the processing so different that it has to be one or the other? And another part of the question is, hemp has remarkable adaptability, thriving in less fertile areas, offering significant health benefits, improving soil quality. How does Miscanthus compare?
Okay, well, the optimal is to get the most out of any crop. So yes, we should be growing them for multiple applications, and not even just singly for a construction supply chain. That's one of the arguments to use existing crops like straws, because it is the straw stem that's effectively the waste from that product, and we're valorizing it. So we're getting a second function out of it. So the same should be argued if we're growing hemp. We should probably try grow for different purposes, although there's also arguments to use varieties that give possibly an optimization, but certainly we need to be getting multiple uses out of the crop, and preferably using waste streams rather than growing specifically for something. And then we're not in it. Like if we're using a food crop and a waste stream from a food crop, then we're not in competition with food. We're just utilizing the waste stream from the food crop. So I would imagine that England has as healthy a tillage crop sector as Ireland has, and there's huge tonnage of straw available already. But that's probably my thoughts on the first question. The second part was about Miscanthus. Yes, Miscanthus is a very attractive crop in terms of its hardiness. And the fact that it's a perennial actually makes it one of the lowest carbon emitters. I wasn't aware of that till we started this project. But there's a very different carbon profile from miscanthus done for hemp and straw, which are being planted annually with significant energy intensity in the planting process. Whereas if you have a perennial, you plant once and you're going to get 20 years out of that, plus huge soil benefits. In Germany, miscanthus is being planted as a soil remediation crop in industrial areas where there's been soil damage and pollution. And I believe in some areas it's also being planted for water control. So again, it's a crop with multiple benefits. The perennial nature of it, I think, makes it quite specifically interesting from a cost and a carbon basis. Farmers like the perennial aspect to it in terms of cost, but cost base and but it's a different material. It's much tougher than straw. It's slightly different to process, but it can be processed both in terms of, it can be fiberized and it obviously can be chipped. And there are examples of people using miscanthus quite effectively as an industrial crop, getting 10 or 12 products out of miscanthus in a way that we would think only of hemp. So in Germany, miscanthus has been used as an industrial crop for extracting all sorts of resources, including silicate. So I would say that what we either strategically utilize crops that we already have, and we're utilizing the waste output of an existing process, particularly if it's a food crop and we're not in competition with food production, or if we're planting industrial type crops, that they should be planted to get into as many sectors and as many applications as possible, and construction should be just one of them. I think that's the healthiest way to ensure the supply side, that it has diversity, it can shift with markets, and it's got a diversity of processing. And construction should be the lowest grade application of the materials, because we don't need high quality materials to do a lot of what we want. We just need something that's conductive. It has low conduction and high carbon, and it's hygroscopic, etc. So we don't need necessarily really high quality. We just need lots of volume. So I think when you start looking at the supply chain factors, really anybody from the feedstock side, we should be looking at, I'm growing a crop for a multiplicity of applications, as many as possible, and that's the safest market context for them.